Hello friends, welcome to my video lecture series on difference equations. First, let us define what is meant by a difference equation. An equation which involves the dependent variable y, independent variable x together with some difference terms. So what are the difference terms? We have studied the difference operators in the discussion on finite differences. So delta y, or in fact we can call it as delta y of x if it is of first order, delta square y of x. So even we can have delta cube y of x and so on. So such type of difference terms along with a dependent variable y and an independent variable x, if they are present in the difference equation, if they are present in the given equation, then the given equation is called a difference equation. So now we shall consider an example of a difference equation. So let us consider the first example. Delta y plus 3y equal to 4x. So it is a relation between dependent variable y, independent variable x along with some constants, and at the same time a difference term delta y is present in the equation. So this is an example of a difference equation. Similarly, we can have another equation, that is delta squared y plus 2 delta y plus 4y equal to 5x. So this can be another example of a difference equation. So in fact, we should try here to know what is the value of delta y. We know that delta y is the difference of the value of y at the forward point, that is x plus h, minus the value of y at the point x. So delta y of x, we can denote it as delta y of x, that is equal to y of x plus h minus y of x. Similarly, if we want to have delta of y of x plus h, then it is, so first of all we should know that here the point x will be there. If we have a jump of h, we will be having the next point x plus h, that is the point which is next to x will be x plus h. Similarly, here it is another jump. If we have from x plus h, it will be x plus h, that is x plus 2h. Similarly, we can have x plus 3h here, and we can have so on so forth like that. Now the corresponding values of y at x will be denoted as y of x. For our convenience, let us take it as yx. The value of y at x plus h can be taken as y of x plus h, or it is y of x, y the subscript x plus h. The value of y at x plus 2h may be denoted as y with subscript x plus 2h, and so on. So now the value of y, the difference, the first order forward difference of y at x plus h will be the value of y at x plus 2h minus y of x plus y at x plus h, that is y of x plus 2h minus y at x plus h. So if we denote y of x plus h as y with subscript x plus h minus y at x, it will be looking like this, and this will be looking like y at x plus 2h minus y at x plus h. So this is how we can have the values of delta y of x, delta y of x plus h, in general delta y of x plus n h. So these are the first order forward differences. And in the same way, we can define the second order forward differences. So the second order forward difference delta squared y x will be the value of delta y at x plus h minus the value of delta y at x. So these two, delta yx, delta yx plus h. So delta yx plus h minus delta yx is the value of the second order forward difference delta yx. So this is in fact y of x plus 2h minus y of x. The value of this is this bracket minus this bracket. So y of x plus h, and this is minus y of x plus h. It is minus 2 times of y x plus h it is going to be, and therefore we will be having here the value of second order difference as y of x plus 2h minus y of x plus h minus y of x plus h minus 2 times of y at x plus h minus this is going to be plus, because we are considering here minus of delta y of x minus of delta y of x minus plus yx. So these are the things we are having for second order for a difference of y at x. So in this way we can have the values of the forward differences which are to be substituted in the difference equation which we have denoted here by the equations number 1 and number 2. Before going to substitute them into equations 1 and 2, let me tell you one thing, that if we choose h equal to 1, that will be a better choice for the understanding of the theory. That is, we will choose h equal to 1 for our convenience and for the simplicity of our discussion. So if we choose h equal to 1, it is going to be y of x plus 1. That will become y x plus 1 minus yx. So this will look like y x plus 1 minus yx. Similarly, this will look like y at x plus 2 minus y at x plus 1, and this in fact it will look like y x plus 2 minus 2y x plus 1 plus yx. So these are the values we are having here when we choose h equal to 1 for the sake of simplicity of our discussion. Now with the substitution of these values into the equations 1 and 2. So equation 1 now implies delta y is yx plus 1 minus yx plus, this is the value of the first term, we are writing it in a bracket, plus 3 times of y, the value of y at x, that is yx, that is equal to on RHS 4x. So if we simplify this, yx plus 1 minus yx plus 3yx, that is going to be 2yx. So this implies it is yx plus 1 minus yx plus 3yx, that is going to be plus 2yx, minus 1 plus 3, that is going to be plus 2yx, that is equal to 4x on RHS. So this is how the difference equation looks like in the usual form. So we will be considering this type of equation and we will be solving the given difference equation. So this is of our interest. Now what happens to equation number 2? In the same way we can simplify by substituting these values into equation number 2. Then what happens to equation number 2? Let us see. So equation 2 will now look like, the value of the first bracket is here, that is bracket yx plus 2 minus 2yx plus 1 plus yx plus 2 times delta yx is yx plus 1 minus yx, it is over. So we have substituted these two values here, plus 4 times of y, of course it is y at x, y of x, that is equal to on RHS we will be having 5x. If we simplify, yx plus 2 will be as it is, This is minus 2yx plus 1 plus 2yx plus 1 cancelling out. So totally yx plus 1 goes off, plus yx plus of minus, it is 2yx, 1yx minus 2yx plus 4yx. So it is totally 1 plus 4, 5u minus 2 is plus 3 times of yx, and on RHS it is going to be 5ux. So this is the second difference equation we are having. So at this moment I should tell you that the difference equation is generally a relation involving the values of the dependent variable y prescribed at different discrete values of x. I have shown you in the beginning itself, this list is giving us the values of y at different discrete values of x. That is the value of y at x, that is yx. The value of y at x plus h, that is yx plus h. The value of y at x plus 2h, that is yx plus 2h. In this way, we are having a list of values of y prescribed at different discrete values of y, and the relation between those values is called as the difference equation. This is the most important form of the difference equation. We will be considering the difference equation in that format and trying to solve the given difference equation. One more thing I should tell you here, that we have dealt with an operation called as the shifting operation, and it is denoted by E. E is a shift operator, and if it is operated on y of x, or in fact yx, E of yx means the jump of y onto the next point x plus 1. So E of yx means the value of y to be considered at the next step. So it will be shifted to the next point. Therefore, the shift operator, if it is operated on yx, the value becomes yx plus h, or yx plus 1 in this case, because we are choosing h equal to 1. Now, if we write yx plus 1 as E of yx, yx plus 2 is nothing but the second order shift operator operated on yx. So yx plus 2 means 2 times we have to jump from the point yx to get yx plus 2. So that is denoted by E square. If we substitute those values here in these equations, so the equations will look like this will become E of yx plus 2yx equals to 4x, or it can be written as E plus 2 operated on yx. By taking yx common, I can write like that, and on the right hand side it is 4x. It is 4x. So the equation, the difference equation, which we initially considered like this, has been converted to this format, and now it is further converted to the another alternative format, that is E plus 2 operated on yx equal to 4x. Similarly, this equation will be like E square of yx. I will write yx outside here. So it is E square, second order shift operator E square, plus 3 times of yx equals to 5x. So this is another form of the difference equations which we will be considering in our analysis. So this is how one can define the difference equations. Now we shall discuss what is meant by the solution of the difference equation. The solution of the difference equation is value of the unknown. So what is the unknown here? If we look at this equation, yx is the unknown, If we look at this equation, yx is the unknown. Wherever we see yx is the unknown, that is y of x, the value of y at x, that is the unknown, that is the dependent variable itself is the unknown. The value of yx which satisfies the given difference equation is called as the solution of the given difference equation. Very simple definition. The value of y of x, which is particularly a relation between independent variable x together with some constants, and which when substituted into the given difference equation, the difference equation must be balanced. That is, we should have LHS equal to RHS. So such a value of the dependent variable yx, such a value of the unknown yx is called as the solution of the given difference equation. So this is one important definition. Another important definition we have to consider here is about order of the given difference equation. What is the order of a difference equation? Order of the difference equation is the difference between highest argument and the lowest argument present in the difference equation. So what are the arguments? The arguments here means x plus 1. If we write y of x, that x means argument. So here y of x, y with subscript x plus 1 means x plus 1 is the argument. So the difference between the highest argument and the lowest argument present in the difference equation, that value is called as the order of the difference equation. So this equation, in this equation, yx plus 1 minus x, it will be 1. So this equation, the first difference equation which we considered, is a first order finite difference equation. Whereas this equation, in this equation the highest argument is x plus 2, the lowest argument is x. So it is x plus 2 minus x, the order is 2. Therefore it is a second order difference equation. We can look like this, or we can look at the same thing in a different way. Here if it is e square present or delta square present, the highest order difference term is delta square. If the difference equation is displayed in this format, then we have to find out the highest ordered difference term, that is 2. Therefore the order of the differential equation will be 2. If the difference equation is represented in terms of the shift operator, if it is e square present, then we say that 2 is the order of the given difference equation. If the difference equation is displayed in this format, then we have to consider the difference of the highest argument and the lowest argument, and that answer will be the order of the given difference equation. So this is how one can define the order of the difference equation. Now what is meant by the degree of the difference equation? So the exponent or the power of yx, yx plus 1, yx plus 2 terms which are present in the given difference equation, that exponent value represents the degree of the given difference equation. In fact, both the difference equations available here are having the power 1. So therefore these two difference equations are of first degree. We can observe everywhere. So the difference operators which are present in the difference equation are having the degree 1. Therefore the difference equations are of first degree. Now we will discuss a very important class of difference equations called as linear difference equations. So what are meant by the linear difference equations? This is another very important term I am going to define at this moment. A difference equation is said to be linear if the degree of the difference equation is 1 and there will not be any product term between yx with any of the difference terms, that is yx plus 1, yx plus 2, they should not be multiplied together. And even we cannot have the product terms like yx plus 1 with yx. So what I am telling you here, there should not be any term like yx into yx, that is yx square. This makes the term second degree. So it should not be there. Degree should be 1. So this is not allowed. And yx should not be multiplied with any of the differences. Yx should not be multiplied with yx plus 1. Yx should not be multiplied with yx plus 2. So this is the second condition. Dependent variable should not be multiplied with any of the difference terms. And two difference terms also should not be multiplied. That is yx plus 1 should not be multiplied with yx plus 2. Or even yx plus 1 should not be multiplied with itself. Yx plus 2 should not be multiplied with itself. So if it is the case, then we call the difference equation as a linear equation. So once again I will define. A difference equation is said to be linear if it is of first degree and the dependent variable yx should not be multiplied with any of the difference terms and no two difference terms are multiplied together. So if this is the thing given in the difference equation, then the equation is called linear difference equation. So with this, let me conclude now. In the next video, we shall discuss about the two different types of linear difference equations of order 2.